So, continuing our SDR theme for this morning, Mike Seguin, N1JEZ, is going to talk about the LimeSDR, which is one of the new pieces of hardware that's very microwave capable and a really good fit for the kind of thing that John was talking about earlier. So, Mike, take it away.
No. Let's see. We want to get the presentation up here. Yeah, let's do that. Not sure where you put it. Good morning. LimeSDR. There it is. Excellent. Oh, no. Oh, just... There we go.
Thank you, Michael.
There we go. And I'm looking for the clicker. There we go. Got to have a clicker.
And it has a pointer.
Pointer on top. Great. Okay. I was going to talk this morning about the LimeSDR, and basically an update of a paper that I started about 2 years ago when the Lime first came out. And also a new chip that has been put out by Lime called the LMS 8001. It essentially extends the LimeSDR from its top range of 3.8 gigahertz up to 5 and 10 gigs. It's basically got continuous coverage up through 10 gigs. So we'll talk about that one. Did anybody notice the carpets in this building? Yeah. Doesn't that look like a scope mode on a pan adapter? Now this is the north corridor, if you've noticed that one. But I came walking around here in the south corridor. Somebody turned on the audio processor, I think, on this one. It just got a incredible. It's a K3, I think. They look like that when. Okay, the LimeSDR. Is everybody sort of familiar with it? If you know where it came from, what it was, and basically it was a crowd-funded project. Software-defined radios started back in 2016, of April of 2016, and within a few months they had $500,000 fully funded on the project. People jumped on it pretty quickly, and finally in February of 2017 they started arriving. The boards themselves started arriving, and they were funded to $1 million over the top by April of 2017. So very, very successful crowd-funded project for this particular one. Initial backers like myself that got in, like the first 100, 150 backers, we were able to buy the board for $199, which at the time was quite interesting. This is a chart of the when the board first came out, of comparison between various SDRs. And what turned out to be very interesting was the specifications that you see. It's very much like an EDIS B210 as far as RF bandwidth, 61 megahertz that it can do, 12-bit A to D, full duplex MIMO, or multiple in, multiple out. It has 2x2 channels built onto it. And the big one that I think drew a lot of people was the pricing. When they did come out, they were $299 versus somewhere in the $1,100 range. So a lot of people started looking at that pretty carefully on these boards. The basic specifications of this board is, as I said, it's MIMO, multiple in, multiple out. There are guys using these boards as cell sites. They've got, in GNU Radio, they've got cell sites running on these little boards. They are what's called an FPRF chip, field programmable RF chip. On board is an FPGA. They use Altera's Cyclone 4 series, and it's USB 3. Highly recommended that if you're going to play with one of these things, you really want USB 3 for the throughput. These things can do a big amount of throughput. Oscillator on board, pretty decent onboard oscillator. Continuous frequency coverage, 100 kilohertz to 3.8 gigahertz. That's kind of a gotcha. On a lot of these SDRs, you got to be careful. Even though they say they cover 100 kilohertz to 3.8 gigahertz, they may tune there, but not necessarily always operate efficiently over that full range of bands. It has to do with matching networks, which we'll look at in a little bit. Bandwidth, 61 megahertz, 61.44 megahertz of bandwidth. little UFL connectors on the board and status LEDs and things like that. So kind of an interesting board. This is what it looks like, the whole board itself. Fairly busy. Basically, FPGA, USB chip. This section out in back here, that's the RF side of the board. That's the LMS 7002 here. But on the basic board, if you have GPIO on here, external power in, your USB interface, you have the ability to put in a reference clock here to lock it externally, some nice little status LEDs, and pads where you can wire off the LEDs to be used for indication outside the panel. It comes with temperature sensing on here and fan control. You can actually hook up a fan on these and it'll automatically be controlled. Once you start pumping 20, 25 megahertz of bandwidth out of these chips, they heat up. So you want some way to monitor that and keep track of it, and it's on the board. Let's look real quick at the block diagram of the chip. It's pretty busy, pretty darn busy, very, very busy. It's essentially, you have 2 receive channels here, and each receive channel has 3 inputs. So you're talking about 6 RF receive input channels on this board. On the TX side, you have 2 ADC channels as well, and 2 TX outputs on each one of those. So you've got a total of 10 ins and outs on this board that you can use. And remember, we're talking MIMO. Multiple things can be going on at the same time with these boards. Here's what mine looks like in a case, and I'll pass this around. I took the top cover off it so you can look at it. That's it. That's the Lime. These cases were available on eBay for, I don't know, 20 or 25 bucks or whatever, the whole case and everything else. But looking at the front end here, USB connector, I wired these LEDs out into the front. They're dual color LEDs. External power in here. This is your reference clock in and out for locking the system, 10 megs. And here's the output side. You can see the 2 channels, TX1, RX1, and TX2, RX2. 3 inputs on each side, 2 transmits on the other side. Inside, that's what it looks like. It uses UFL connectors, so you can buy UFL to SMA for real cheap on eBay. It's the type of connector we use on GPS modules and things like that, so it's very, very easy. I wired in all the LEDs here that you'll see when we pass it around. And pretty compact case. I took the top off, but that's where the fan hooks on. You just wire it in here and it's automatic. It's just away it goes. What I really wanted to concentrate on this morning was software. A software-defined radio is nothing without software. And that seems to be where we're getting better and better at software. And what I would say is as we're going through this, please refer to the paper in the proceedings. It has all the URLs for all this software, so if you're interested in any of it, you can just go directly there with the URLs, and they're up to date as of about a week or 10 days ago. So they're very, very much up to date. So there's more information than I'll get into this morning here. So basically, I'm going to concentrate on Windows software, as most of us are Windows users. There are Linux users here, and I use Linux on occasion when I absolutely have to. But anyway, probably one of the best packages that you'd want to grab to start with is what's called Pothosware. It's a combination of several packages in one download, and basically you'll get Pothos GUI, which is very much like GNU Radio, flow graphs and beauty screens and things like that. It also has a program called GQRX, a receive system, Cubic SDR, GNU Radio, which comes with it as well, and then the control program for the Lime board itself called LimeSuite GUI. You need that to be able to get into the board and do low-level things. It's really nice. It's a nice piece of software. It's well laid out. It's one place where you can go in and you can really screw up the board easily. You don't have to use any other software, just that one there, and you can mess it up really bad. And the big thing with the LimeSuite GUI software is you want that because it allows you to update the firmware very easily. And there have been multiple firmware updates to these boards, and it's very easy to load that stuff in. We also have SDR console. And people here anybody use SDR console from Simon Brown? It's a very good software package, extremely good software package. HDSDR, we use that for pan adapters in the field. There's an external I/O for that. And also SDR Sharp. There was a plugin that works with SDR Sharp for the Lime. So as far as transmit support, this is the biggie. This is, I think, we're trying to catch up. There's a lot of receive software for these things, but transmit software is a tough one. Somebody came out with a program called Foobar 2000. I'm going, what the heck? That's a great name for a piece of software, Foobar. Yeah, we'll look at that one. That's a good one. Probably one of the up-and-comers, SDR Angel. That one's working quite well. That's what's working well for transmit, and it's well supported. Lots of updates coming out for that. LimeSDR Sharp is another one that came out about 6 months ago. The development on that one is kind of slowed, but that one's working. And SDR Console v3, Simon is going to turn back around and get working on his limes. He's working on the Open HPSDR stuff right now, finishing off some code for that. But his program, we'll look at that. That's going to be nice. Also, there's additional software for it too, like a spectrum analyzer, Q spectrum analyzer, and you can get VNA and URH, which is one of my favorites. URH is Universal Radio Hacker. We'll look at that one. It's a fun one. Basically looking at Pothos GUI, you saw what John showed, very much like GNU Radio, very much, flow graphs. You set them up and whatnot and go through it in your flow graph screens. Here's what the beauty screen for that looks like when you run the software. It has your basic controls. I think I'm looking at, an FM radio station here. At 95.5. It's an FM rock station that I used to be the engineer for, so I just want to look at the modulation. It looks pretty good. They're loud. So that's what Pothos GUI looks like. GQRX, another nice little package of software, receive only as well, but easy to run, works with it. This is looking at the NOAA weather station at my QTH in Burlington, 162.4. And each one of these has various controls, and you kind of look at each package, and some will have controls that you want. One of the things is not all the packages when they first came out allowed antenna selection. So this is one of the ones that actually allowed you to select which antenna you were working with, which was nice to be able to use different outputs and inputs on this. Another package, Cubic SDR, just basically a different layout, different take on the same thing. You've still got pan adapter and audio spectrum, etc. A way to save certain presets. Just basically different types of receive software, but lots of things you can play with here. And of course the big one, GNU Radio Companion. You got to dig into this one to get it to work. The other stuff is pretty much off, plug and play, pretty easy to work with. But GNU Radio, and there's the beauty screen for that with all the sliders and controls. And I think on this one too, I'm looking at the National Weather Service as well, or something like that. Yeah, 162.4. This is LimeSuite GUI. This is the program that you use to basically configure the chip if you want to work with it internally and do your firmware updates. As you can probably see, it's very, very, there's a lot to it. All these tabs up here are different sections of the chip that you work with. So you can tweak just about any parameter you want on these things and play with it. I'll show this screen. It's part of LimeSuite GUI. This would be typically where you set up external 10 meg locking for the system. You can go in here and program the ADF 4002 chip. It's really easy. You basically put in your reference frequency in this box and click calculate RN and upload, and you're done. And it's locked. You have an external input for it. So this was easy to play with to begin with.
Is there a reset to factory default?
Yes. Unplug it, plug it back in. Yeah, definitely. Yeah. Probably one of my favorites, SDR Console v3. Beautiful piece of software. Amazing piece of software that Simon is continually working on and upgrading. What you're looking at is the entire FM broadcast band in Burlington, Vermont at my house. It's 25 megahertz of bandwidth at once. And interesting, you can see various signals in here. I like this one up here, this one that looks kind of wide and funky. That's an FMHD signal off of Mount Mansfield. So that's, if you ever see that with those sidebands, that's what that is. It's FMHD. One of the big things about this software is, you guys heard of CUDA? CUDA processing or NVIDIA video cards? Yeah, Simon uses CUDA. This is running on my i7 at home, 25 megahertz of bandwidth, but if you look at the CPU usage down here, it's like 14.5% on the CPU. He's offloaded like FFT processing to the GPUs and the NVIDIA card, and that's running up at about 20-25%. Very efficient operating software, very smooth. So he's offloading a lot of processing. If you're building a PC, definitely look at NVIDIA cards. They're not very expensive, and you can get tons of GPU cores in them, and this software runs really well with it. HDSDR, a lot of us guys use this in the field for pan adapters. There's an external I/O for it that you can just drop in and select, and it lets you set sample rates and antenna usage and be able to work with that. SDR Sharp. There's a LimeSDR plugin for that. So you can run that as well. So as you can see, there's quite a bit of receive software out there. There's a lot of things you can play with under Windows that, choose one that you really kind of like and go from there. There's Foobar 2000. I grabbed this one initially because it was the very first thing that allowed me to transmit something that other than a tone using the LimeSuite GUI software. This could actually let you play back like an MP3 file. For here, it's set up as an FM transmitter, a wideband FM transmitter on 433, and it was the very first thing that allowed me to actually transmit with the Lime shortly after I got it. So it's kind of in here. It's kind of interesting to play with. Quick look at Q Spectrum Analyzer, looking at the FM broadcast band. There's a whole bunch of settings you can play with in this software, and if you want to use a spectrum analyzer, there you go for software to do various things. That's available. All of these URLs are in the paper. You can go directly to these sites and grab the software, the latest versions, download them, and use them. No problem whatsoever. Universal Radio Hacker. What is it? It's a combination of pieces. It's a spectrum analyzer and also a recording device. You can record the waveforms, record INQ of various signals that you find. And it has the ability to help you dissect the signals, see what they are, and also it can retransmit them. So what would you use that for? Well, let's see. That waveform is my Subaru Outback key fob. So I'm sitting in my shack opening and closing the doors on my car in the driveway. My neighbor's garage door seemed to be mysteriously opening and closing at various intervals. So it's a fun piece of software to mess around with, and it works pretty well. Yeah. Moving on to transmit support. We have 3 of them out there right now that are working pretty well. SDR Angel, as I said, LimeSDR Sharp, and SDR Console is coming. Simon's going to, I'm sure, is going to get around to that to get that running. He has it running in receive already. He's just got to get circled back around to that. SDR Angel. It's written by a guy from France, Eduardo, does a lot of work on this. It's based on the idea of the GNU Radio concept of sources and sinks that you deal with. Sources, inputs, sinks, outputs. You define those in the software up here. For instance, this is a source, an FM source, a receiver, a narrowband FM receiver, and various parameters you set up. And I think that, that's the National Weather Service that you can play with. And on the transmit side, basically set up a sink, an output, and this is what I think I set up an SSB transmitter here. You can see the waveform here where I'm transmitting on 435. and works quite well. Works quite well. SDR Angel is the first one to allow us to turn on the external 10 megahertz input to lock the rig. In his source modules, there's a push button here that allows us to turn on the 10 meg lock, so we can use that. The other softwares don't allow it yet. They haven't got that feature built into it, so this is kind of nice. Those of you with Flex radios probably recognize that, or even the Open HPSDR interface here. This is LimeSDR Sharp based on Power SDR for a front end. So it looks very much like Power SDR, but it's running Lime. So it's pretty good software. This is the first one that allows us to use the GPIO pins on the board. They're there, but we hadn't been able to access them before. We're trying to set up a standard now among the software people that there are basically 7 pins that we're going to play with. 4 of them we're going to assign to band switching, and then we'll have CW dot, CW dash, and PTT on 3 more pins, and try to get everybody to use the same pins for that. That's the way this particular software operates, and it's pretty standard. We want it. Hopefully that'll we can get that to become standard. Yes. Yes, 16 BCD. Yep, standard BCD format. There's also, let me see here. I'll flip this. I want to pan this around. This is the GPI board that they did a spin of on here, and I'll pass this one around. This is this board's kind of overkill for what it is. It's GPI in and out. It's very flexible and works pretty good. It's the same size as a LimeSDR board. It's configurable as far as whether you want the pins to be input and output. It buffers the outputs with the standard ULN, 2003 chip, the Darlington pair chips that are used. Highly recommended if you're going to use GPIO on these boards. The issue is the GPIO is developed off the FPGA, directly off the FPGA. You do not want to hook that to external devices. It's too easy to have something happen to the pins, and then you've got a little brick of FPGA gunk, and don't ask me how I know that. So definitely interface it, and that's one board. That one, as I said, is kind of overkill, but it's pretty good. Basically, the GPI inputs are here. Your outputs are the terminals here that you can just screw terminals, and you literally can set it whether you want inputs or outputs with a dip switch, and there are status LEDs over in here. So it's a nice, easy board to work with. Was not cheap. I forget it was over $100, but for an easy solution, a plug and play to be able to work with, nice little board. And as I said, SDR console for transmit support, that's coming, and that'll be great when we finally get that one, get that software working. It works great in receive, but we really want the transmit support. If you didn't hear when the Lime first came out, it had some severe growing pains, as we call it. Basically, the chip itself can do as I said, a lot of wideband input. The problem is they on the board that you have passing around here, they put on specific matching networks on the inputs, and they are not really optimum if you look at what these are. And what happened when the Lime first came out was everybody saw continuous coverage from 100 kilohertz up to 3.8 gigahertz. So all the HF guys got these, went on 20 meters and heard nothing, because none of the matching networks are even close. So everybody's jumping up and down, and this doesn't work and that doesn't work. So what basically happened is we found out that this is some of the matching networks on the output. On one of the matching networks, we found, take that inductor out. Just take it out. And that opened up the front end, and suddenly, wow, you got 20 meters again, and all the HF guys were happy. It's a little, I don't know, 06, 03, 04, 02 part in there. You just go in with a pair of tweezers and knock it off or whatever. And that actually fixed that up pretty well. Of course, that opened another can of worms when the guys were on 14 megs listening to 20 meters. They were hearing FM broadcasts. There was anti-aliasing going on because of the wideband front end, which is not uncommon in these SDRs with a wideband front end. You can get stuff going on inside and mixing. So one of the simple solutions there was RTL.com. has a little FM bandpass filter, like, I don't know, 10 or 12 bucks. Throw that in line, and that just takes out the FM, and HF is fine. So that was an easy one. So moving on to the actual VHF, UHF Performance when we were playing with it. I started playing with it, and I got to say it was kind of disappointing. It didn't hear well as I thought it should. It wasn't bad, but it really wasn't as good as I thought it should be. So first thing I did was added an 86IW wideband preamp, and that made it much, much better. I think we find with a lot of these SDRs, you kind of need to kind of tweak them, filters and preamps and things like that you're going to need for specific bands, specific areas you want to operate. Even though they can tune there, they're just not optimum. So you end up adding other parts and pieces, which is not a big deal to do. What I found was 6 through 1296 was pretty good. 2304, 3456, so-so. But, this was according to the, readings that I was doing and measurements and things. And I decided, let's try it on the air. Let's just see what it does. So I took it up to my shack up north in FN 44 in northeastern Vermont. I'm out in the middle of nowhere, and it's very, very quiet. And I said, I'm going to go looking for beacons that I normally listen to. So let's go through the bands. This is 6 meters, K1MS. He's about 248 kilometers away, and you can see his beacon signal over in here. That's pretty much what I hear most of the time up there, up and down with band conditions. So 6 meters, not bad. The 2 meter K1FO beacon that we have for the club, the news group club, 400 kilometers away. There it is there on 2 meters. Doing its thing, not bad. 222 K1IIG's beacon, 369 kilometers. You can see it pretty plainly here. It's working. I can hear it, and that's about what I hear it at most of the time. The K2 DLL's beacon, here again, pretty much what I hear. So it's working on the air. 432 K1IIG again at 369 kilometers, no problem. See that one over here. This one was interesting. I actually detected it. It's K1TR's 903 beacon. It's actually in there. You can't really see it in the picture here, but I did see it. The problem here is you can see all this crud. What that is I have to look through a communications mountain, Burke Mountain, which is 12 miles away from me, and it's line of sight right through to get to this beacon. And Ed's beacon is behind there. And there's 902 to 928 spread spectrum ISP up there. So it's a mess. It's a mess. So to even hear it, I was thrilled. But that's the crap you're seeing all around there. That's all the stuff going on up there. There's also cellular up there just below 900 megs like you have. At my station, this is actually after a bandpass can and a reject can. They're getting rid of garbage and junk. But it does work at 903. Yeah. Yeah. K1FO 1296 beacon at 400 kilometers. There it is, right in there. Not bad. It's doing its thing. I don't have, at the time I did this, there were no 2304 beacons on the air. There is now, but there wasn't at the time. So I just used a synthesizer that I have, weak signal synthesizer, and checked it out, and signals there. Same thing with 3456, weak signal there. So all the way through the bands, basically using it on the air, it's there, it's working. So we did a series of transmit tests, to a real quick one. I was interested in phase noise, just a curiosity just to see what phase noise was like. To set it up, it's pretty easy. Here I'm using a LimeSuite GUI. When I first launch it, you'll come in here and you'll see red. You don't want to see red. That's bad. So the first thing we do is in this clock generator tab, you basically hit calculate and tune here, and this locks the system up, and that's step one to get it to transmit. The next step is you come into what's called the SXT tab, type in the frequency you want to put your carrier on, hit calculate and tune, you've got a carrier. After that, you want to make sure there's a bandpass filter in here, an RF bandwidth filter in here. Under TBB, you come in here. I'm using 5 megs. That seems to be optimum for what I was doing. Hit tune and you're done. You've got your carrier, you're on the air, and you can do your testing. That's what the 850 meg carrier looked like. It's basically minus 88 and change dBc per hertz. Not great. It's actually about 10 dB worse than what the spec says. I haven't gotten back to it to see exactly what it looks like, but not awful. Not great, but not awful. So that's about as far as we got on the transmit test. So that's kind of the status of where we are with the Lime right now. We've got more work to do. There's more stuff in the paper in the proceedings than I presented here. But what I really would like to get into, I'll make sure I don't want to run out of time here, is this little board. This is the Lime 8001 companion board. They call it a companion board. It's an evaluation board. This is the board used to extend the Lime. This is good through beyond 10 gigahertz. I've got the board here, and
You're a brave man.
that's the board. Keep your fingers off it, Steve. He's going to scrub his feet on the carpet. And yeah. Yeah. Okay. What the hell is it? What is this thing? What is this board? It's highly integrated, highly configurable, 4-channel frequency shifter using this circuit, and it is MIMO. It's here again. It's multiple ins, multiple outs, and typically extend the range to 5 to 10 gigahertz with this particular board. It's a single chip, up-down RF shifter, and here again, continuous coverage through 10 gigahertz. But the board is laid out specifically for 5 and 10 gigahertz. That's the thing there. All 4 of the RF channels are driven by the same LO. There is an LO on board this thing. It has a serial port interface for playing with it, and it also has loading of operations via GPIO pins. We'll look at that in a minute to show you what that does. USB interface that works with it. It on board has a 40 megahertz VCT XO. It's easy to lock it. There's no problem locking it. And it's also possible to totally disconnect it and use your own off board if you want to do that. The VCO on board runs from 4.8 to 9.6 gigahertz. So you can run that internally on the board. And if you need to, you can divide it down to as low as 300 megahertz for your LO. The board layout, as you're seeing it passing around here, is basically 5 to 6 in, and 9 to 10 out. I really wish Lime had talked with us hams before they laid that board out and maybe made it 9.5 to 10.5. Just shifted it up a little bit, but I don't know. And then the IFs on this are designed for 1 to 3 gigahertz up high for this particular one. There's the block diagram of the basic chip itself. It's the board layout. When the board comes around, you'll see the way the board's laid out, the matching on the boards, and yeah. Unfortunately. Okay, 4 channels. You've got your LO in here. You can see your PLL external reference that you can bring in if you want to run external LO. If you want to totally bypass this section, RF reference is go in here for 10. It'll accept like 10 to 50 megs and lock. LO distribution is in here, driving off to 4 separate channels, 4 separate RF channels that you have to be able to play with. So that's the basic overview of the board itself. Drilling down a little bit, here's an individual channel, individual transmit or receive channel. Each one of these sections is controllable in software. You can enable and power down each section. You also have the ability in these to save what are called profiles, programs, and link them to GPIO pins. So you can set up the board to do one thing, and on GPIO 1, press GPIO 2 and reconfigure the board. So you can play with that.
LO out of it? Like disabling some of those things and use that you running LO straight out? Would you put it as a fixed source for an external?
Probably. basically, LNA, say I was going to build a receiver, basically what I would do is as the input comes in here, say 10 gigs comes in, I'd make sure the LNA is on, make sure my mixer's on with LO injection and out of PA, and there's my output. Turn this guy off. I want to do a transmitter. Turn off the LNA, turn off this mixer, turn on this mixer, turn on that PA. Just click, 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 done. So you configure each channel that way.
How do you manage differential out?
Matched on the board. You see on the board there's transformers. There's a chart in here that'll show the transformers in a minute, which ones they are. To play with the board, it uses a virtual COM port. There's software you download, and Windows, once you get it loaded correctly, it'll come up as an STMicro virtual COM port device here, and that's what you play with it. LimeSuite 8, another program, is used to control this particular program. You have power options for the board. This is kind of important. You can run that board on USB. The problem is don't do it. Number one, USB is noisy. Number two, there can be limited amount of power you get out of the USB port. So this board allows you to have an external 5-volt input, and you can tell it to use an external supply just by changing a strap on that board. It will allow you to do that. It's very easy to do. Now the MCU on the board, the microprocessor unit on the board, is always powered off the USB port. That's not a problem. But this lets you drive all the RF from an external clean power supply. If you look at the board, here's what it looks like. You're seeing it go around. Basically, your 5 and 10 gig ports are up here, the SMAs. The UFL connectors that are down and around here are your IF ports. And then some external, your external LO injects in here, and reference clock into here if you want to use it. So say I want to build a 10 gigahertz receiver. What I basically do is I look for 10 gigahertz, and it tells you we're going to use channel C, and it's an input, and that's jack number J7. John, there's the transformers. They're doing the matching. So basically we know that the signal is going to come in J7, and it's going to go out, the IF will come out J10. So you're going to come in J7 here, and J10 I guess is over here, and that's it. So how do you configure it? This is LimeSuite 8. Essentially, the first thing you want to program your LO. So for this one, I chose 9.072. I'm going to do a 1296 IF. So I just plug in the frequency and hit Simple Tune. Done. The next thing I need to do is I need to make sure my LO distribution, where am I sending the LO, which RF section? And we know it's channel C that we want to play with. So you just click the box, channel C, your LO's where you need it. So that's easy. Next you jump over to the channel panel here and select which channel you want to operate on. We want to operate on C. And basically the way this works is if there is a check in the checkbox, it's turned off. This is what's called a power down box. You can see here, it's kind of reverse of what you think. You'd think check mark turns it on. It's the other way around. So for this one, I've got the LNA turned on, the mixer turned on, and the little amplifier turned on, and I've turned off this mixer with check marks. I'm done. That's all done. And that's where you can strap to your GPIO pins and masks up in here, and you also can see where the various programs can be saved up in the various tabs here. So I've just created a very quick 10 gigahertz receiver. Throw a VJB board on one side, plug in the Lime, and you're done. Want to do 10 gig transmit, uses another set of channels. IF in here is going to be a channel A in, because that's the channel that we're going to use. It's the A channel for 10 gigahertz, channel AO. So we're going to use J5 and J8. So J8 here and J5 down in here, and the same thing. This particular one, I was playing with something else, I think. But, same thing. Throw in your LO frequency you want. Click on Simple Tune. Make sure your LO is going to which channel you want. And in here, you just turn off your LNA, turn off the mixer, leave this mixer on, leave the amplifier on, and you're done. Oh, is it Smart Tune? Yeah. Okay. Smart Tune. Yep. I'm thinking Simple Tune. Yeah, up on top. Yeah, Smart Tune is the one you want at the bottom. Smart Tune is yeah, not Simple Tune. Smart Tune at the bottom. So that's basically setting up 2. And there it is, just sitting on my desk at home, just real quick and easy. I mean, there's just not a whole heck of a lot to it to really make the thing run. Yeah. Oh, yeah. He's. So anyway, a quick look at some transmit tests we did do on the 10 gigahertz transmit section. The IF runs up at about +9. I set the LO. -7 dBm is what I'm getting out of it, barefoot, out of the board. I did measure the LO leakage. I was just curious, real quick. Respectable. Yeah. I tried 5 gigahertz transmit. Michelle will see the number that's in there. That's the new AMSAT, one of the AMSAT satellites, the 5 and dime satellite. The uplink for that in that area. So I was just messed with a 13.5, 4.5 gigahertz LO and +6 and -53 on that. So yeah, pretty decent. I did test up here. And you can see the roll off. I wish they had maybe moved that slightly higher, but still it's not bad, -7. Yeah, gain is cheap, exactly. And on this particular board, to set up the locking, you can use like between 10 and 50 megahertz external locks in to lock the board down. You basically bring this screen up in the Lime 8 software, put in your reference frequency you want to use here, and click calculate RNN and upload, and you're done. And it's locking. And there's an LED on board that will be red if you don't have a lock, and green when the lock is there. So that's basically that board.
What's that little rascal cost?
$299 in that version right now, where they have it. So that's basically the LMS 8001. Good, I'm about on time here. Something that I just noticed, I was at the LimeSDR website, and this is kind of interesting. They just started listing this, the LMS 9000, and that's... We're going to have to watch this one. We're definitely going to have to watch this one.
I've got a LimeSDR story for you.
Okay.
Society of Amateur Radio has gone through, got into it years. They were in on early development. They had those logos. Looks like these guys have spent something.
Yes.
You know, it took a little while for them to try and learn.
Yes. And they're still learning. There's a lot of firmware updates coming back from users, things that aren't quite right, and a lot of stuff going on. There's not an awful lot of ham radio stuff that I see. There's a group of us, but there's more people playing with 3G, 4G, things like that on these boards. I think that we see a lot of that.
5G now.
Yeah, right. Yeah, to be announced. Well, it was interesting when the LMS 8001, it had the same exact thing, to be announced, and everybody said, oh, vaporware, but it's going around the room now. So we live in some interesting times, I think.
Is that another run of?
I don't know if they're going to do it or not. And so far, no. It's too bad. Yeah, it's a fun board. I mean, I was, you want to build a 510 gig transmitter receiver in 5 minutes. There you go. Something quick and simple and dirty to get going, but whoops. Any questions? Me at a young age, I loved radio.
Okay. When I'm trying to acquire a really weak signal in the field, I rely on my pen adapter to make a tiny little blip visible, even if I cannot hear it. Is there potential, given the I&Q signals that I have available, and if I use a good sound card, is there potential for some software packages to differentiate themselves and how well they can make these really weak signals visible, or is that more or less a hardware limitation and there isn't much software difference?
Typically, for digging weak signals out of the noise when I'm doing it in the field with the software is you reduce the bin size. That's what you do, increase FFT, reduce the bins down. Yeah, how far down are you going? Like HDSDR, I'll go down sub 1 hertz, like 0.7 of a hertz. Yeah, and that will help you as much as anything to pull these signals out.
Carry the noise, baby. If you
Yeah.
want to carry your noise, you ain't nothing to do.
There's an interesting mode in HDSDR if you've got some really weak CW where it can pick that up and regenerate it. I've used it with a couple of contacts with Tom, WA1MBA on 78 gig, where he was extremely weak and EME weak, but the software actually literally grabbed it and regenerated it. It's like the old-fashioned RIDI regenerators we used to have that would take a crappy signal and then regenerate some good stuff. So, yeah.
And this is more of a comment. Q Spectrum Analyzer only runs if you have a very old version of Pothos. The new versions of Pothos kill it.
Kill it?
Because that makes use of Simple SOAPy, and Simple SOAPy's library went from 0.5 up to 0.6, and then like 2 or 3 versions later, they removed 0.5 from the distribution, and so it's dead, and the author doesn't seem to be updating it.
Doesn't seem to be updating it? Yeah, yeah. It's Python-based. Yeah, so, cool. And I'm sure I'll get those boards back when they come back around.
You only said one or
Right.
Mike, you mentioned one of the things that was available was a VNA package. Can you say something about that?
Yeah, it's under Python. It's in the proceedings. It's got everything in the proceedings, including the URLs. It's all in there. It works pretty well. I've tested a few things with it, and I had to build up a bridge to be able to work with it, but no big deal. No big deal. But in the proceedings, that's got everything you need. Yes.
What's the current price of the lime?
What's the current?
Price of the lime.
Oh, $2.99. Yeah. And then add a case, and then add some filters, and then add. Yeah.
Mike, have you worked with the Lime Mini at all?
No, I have not. But I can tell you that Simon Brown has one, so he's going to, when he does his thing for SDR console, he'll pull that one along as well, too.
I'll grab it real quick. The 9000, do you see that going beyond USB 3, like needing, internet, Ethernet kind of interface? Have said anything about that?
They haven't said anything about the interface there, but I'm not sure the throughput is going to need, bandwidth, 2 gigahertz, yeah. Well, I know one of the things the Open HPSDR guys are doing right now, they've gone to PCIe. You've got board inside, and over USB 3. Oh boy, another cable, another plug. Yeah.
My question has to do with when your waterfall displays of some of the weak beacons, like in 2 meters. If you can go back to one of those, please. That's good. Any one of those. So right in the middle with your tune to, there's a little signature, and I see that on my pen adapter. And what is the significance of that? What causes
that's
that?
the DC offset spike right in the middle. Software will get rid of that. This is an early version of SDR console. And Simon didn't have it kind of tweaked and whatnot, and they'll get rid of that.
I'm sorry, what did you say the cause of that was?
DC offset spike. It's a DC center spike.
Okay.
You see it in a lot of the SDRs. Certain software is much better at suppressing it. What I always do, you notice I was tuning one side or the other, and never get in that center. If you want to listen to 144.2, don't tune to 144.2, or get off one side or the other by at least 5 or 10K.
Mike, I'm going to regret asking it this way, but is it me, or is the LimeSDR website a little hard to deal with? It seems like trying to buy one, that was the last thing they were wanting to do, was to sell one to you.
Yeah, it's crowd supply. You got to get the crowd
Yeah.
supply. Yeah,
It was like, wait a minute.
yeah, they're kind of all over the place.
Yeah.
They have a pretty good wiki though that has got a lot of
Yeah.
information, and the Myriad RF forum is quite active there. But yeah,
It's the information was there. We was just buying one that seemed to be the hard part. You know,
take my money, please.
Yeah. Well, and I'm a little bashful about, throwing my money around on the web anyway, so.
Yeah.
All right. Any other questions over there?
Don't know much about it. I think it's what, a single input output. You have one, don't you, Renee?
Yeah, I have one, but it's lower in price. Only with 58.
That could be an option too. I think that's $199 or yeah.
It also has narrower coverage. It starts at 10 meg.
So it's a more realistic spec. Yeah. Okay. Great. Thank you.
Thank you, Mike.